Hey guys, welcome back. What we're going to do is continue our discussion on polynomials. In this case, we're going to be specifically dealing with the division of polynomials. Here's some vocabulary I'd like to present you guys. Passively, if you just want to jot these down so you can be on the lookout for them as we move along this week. More actively, if you want to look these words up in that textbook that's available on Schoology, hit the glossary. It'll pay off big time in your understanding, and of course come test time, as you saw this last Friday. Moving forward, this division of logarithm, what I'd like to do before I get into an exercise problem is make the connection between old school arithmetic long division and polynomial long division. Alright, so here you have your dividend in both cases. Alright, here just a number, here some kind of, in this case, a trinomial, right? Then out here you have your divisor, same thing out here. Here you're dividing this trinomial by a binomial, both of them divisors. And what results is your quotient, okay, in both scenarios. And the math, right, how many times does 12 go into 27? 2. 24, subtract 3, bring down to 7. Right, then how many times does 12 go into 37? 3 times 3, 36, subtract the 1, right? Been there, done that. Same logic here is we want to find out how many times does this binomial go into this binomial. Forget the plus 7 for now. And we'll notice that, right, if I have an x, I need to multiply times a 2x, so I can get a 2x squared cancel there. So I'll do that, right? X times 2x is 2x. Then I must take this 2x and multiply with this 2 and get 4x. So now I subtract out here. And I've got this on purpose is going to cancel. Eliminate that term. Now I've got 7 minus 4, which is 3x. Bring down to 7 plus 7. And I ask myself again, how do I get, how many times does x plus 2 go into 3x plus 7? Well, really focus on that first, or that leading term, right? So x times something will give me 3x times 3. So 3 times x gives me 3x. I must now multiply this 3 to the 2, which gives me a 6. And once I subtract that, I've got this canceled, and 7 minus 6 is 1. Okay, that's just like a crash course into this material. Now let's go ahead and look at our own problem. So here we have a trinomial divided by a binomial. So let's go and set this up. All right. And we're going to be using this language as much as possible. So we've got our divisor, our dividend, and our quotient. Alright, so inside is our dividend. Right, now notice that it's not in standard form. So that's actually the first place we should start. So I'm glad we got a problem like this. Notice, okay, just like you can't have the ones place up in the front, right? It's got to be organized. Same thing here. You've got it in standard form, the highest exponent, and then it trickles down in that order. So here, as you can see, I'm going to need to rearrange these. So I'm going to go my highest exponent term, and then I've got a 5x, then I got a minus 8. Now the other thing you'll notice is, hey, there's no x squared. Well, one, that's a good observation. Two, you can quickly adjust for that. Alright, this way. Plus 0x squared plus 5x minus 8. It's the same thing as saying, hey, the number 203, if I divide it, can I just ignore that and leave it as 23? Heck no, right? This is very important. It's like a placeholder, and that's all we're doing in our case is, hey, there's no x squared, but we need to carry out this long division, account for that. We'll call it a place value, all right, to kind of make the connection. So anyways, let's go ahead and do the little division sign. Again, in here will be our dividend, which is this guy right there, plus. Alright, some students came in, but we got that rectified. So anyways, we've got our dividend up in here, now in completed standard form, we can call it. Okay, because this is standard form technically, but right, filling in the gaps, it just does everything for you in terms of long division. Sorry, lost my train of thought. Alright, let's get to it. So I want you to kind of follow this train of thought. It's a little intuitive because you've done stuff like this before, and then there's the fact that they're polynomials. So just hang in there, kind of follow this train of thought. So as I look here, right, I ask myself, hey, how many times does this x divide into this, which is a little counterintuitive. I think most of you guys would be more comfortable saying, hey, this x times something gives me 6x cubed. Well, it's pretty obvious, at least to the bulk of us, that it'd be times 6x squared, okay? So I'm actually going to line my 6x squared here with this term that has an x squared. Now, the book and other places might line, see how this is x to the first power and it's lined up over the x squared. It's a preference thing for our class. Okay, I'm going to insist that we line them up, all the terms. It just keeps everything so nicely organized. So anyways, here's what I do is I'm going to assume that x times 6x squared gives me 6x cubed, which it does. So now I'm going to carry out that multiplication. And 6x squared times x is 6x cubed. Now I must carry this, multiply this monomial with this other term. So this would give me a minus 12x squared. Alright? Put the minus sign. I will put parentheses because that minus sign distributes and we don't want to forget that. The other thing I want you guys to notice is that how everything, all of my x squareds are lined up. Okay, that is a nice little gauge as to, am I doing this right? Right, because it's just that extra organized. Anyways, so sure enough, this cancels, okay, disappears. Now I have 0 minus negative 12x squared, which is essentially a positive 12x squared, so I've got 12x, right, squared. The next thing that I want to do is I want to bring down the next term, so I bring down the plus 5x. And same question is I say, hey, this x divides this, right? Or x times something gives me 12x squared, and most of us would say, hey, 12x. Right? Once again, look at all the x's lined up. So 12x times x is 12x squared. 12x times minus 2x is minus 24x. Right? Let's go ahead and subtract this. Parentheses so that I don't forget that minus distributes. And this cancels awesome. I've got 5 minus a negative 24, or 5 plus 24, so I've got 29x. And bring down this last term. And the question again is, x divides 29x, what do you get? Or x times something gives you 29x, and the answer is 29. Alright? Times x is 29x. 29 times minus 2 is minus 58. We're going to put parentheses on that, subtract these quantities. Okay, these leading terms cancel. Then now I have, careful, negative 8 minus a negative 58, or negative 8 plus 58. So I will leave me with 50. Right? So 50 is essentially the remainder. So what we can do here is we can add a plus 50, right? And here's our divisor, okay? So with that said, here's our dividend, here's a divisor, and here remaining is our quotient. Guys, thanks for your time. I'll see you tomorrow.